Hey friends, welcome back to the channel. My name is Alex and today we're going to talk about Spring and aspect-oriented programming. So you may be wondering, what is aspect-oriented programming, or AOP for short? So in general, the idea is that we have cross-cutting concerns in our applications, like things that we repeatedly have to do, and we can just put them in individual components and reuse those instead of having the code just duplicated. So this goes for features like security and as well for rate limiting, which is what we're going to use today. So in this tutorial, I want to show you how you can invoke a third-party API, and we're using the actual Twitter API to do this. And this API has rate limits in place, so it allows only a certain number of requests per time interval. So we just want to make sure that our application plays by these rules. And the way we do this is by using Bucket4J, which is a library especially made for rate limiting. So we're gonna use that, and then eventually we just add everything to one aspect and apply that to the code. So that's the idea for today. So without further ado, let's code. Okay, so in the IDE, let's quickly look at the dependencies. I'm using Spring Boot 2.7.2 and I'm using the AOP starter, which is all that we need here. I'm using the official Twitter Java SDK, which seems there's an update already, but we still, oh no, there's a vulnerability, but we don't care about that at this point. So that's fine. And then there's also Bucket4J, which we're going to use for the actual rate limiting. So the way we're going to do this is we start with the actual properties, because in order to talk to the Twitter API, we need credentials, and I have them here. I have this in the secrets YAML file that I'm not going to share here because it's my actual key. But this is what it looks like roughly, because this is the application property file that's going to be loaded. So we have a configuration for Twitter, the properties for key, secret, and Bira. I'm only using the Bira token here that I have pre-generated to make the API requests. And the secrets YAML file that is here is just loaded like this, so I can optionally add it, and it's going to override these properties. I could also add them in variables to the environment, but I'm using that approach. So first order is to just map these properties to something that we can use. So in order for these properties to be used in the application, let's create a new component. And as you may know, I'm not a big fan of injecting properties directly using the add value annotation. So we're using something like this, Twitter properties. I make this a data class, and I just want to have the Bira token here. That should be good. And I can make this configuration properties prefix Twitter, and I get to that in a second. I need to check, so that's constructor binding. So these should be the things that we need here. And it's missing the boot configuration annotation processor. We just don't care about that. But there's one thing that we need to do, which is a little bit large here. We need to register the properties, which we're going to do in a second. So what we need next is a configuration, and we use a config that's taking care of the properties and then populating an instance of the Twitter API, which we're going to use. So we're going with configuration here, and I also enable configuration properties. I'm using the one that we just had created, Twitter properties class. That should be good. So we have a configuration here. That means we can add beans to the Spring context. So let's call this one API, and we're injecting the properties here, Twitter properties. And now we're using the official Twitter SDK to return a Twitter API, and we configure it with a Twitter credentials Bira, passing in the Bira token. So that should give us a perfect configured instance of the Twitter API, which you can already use now to make API calls. So, but there's one additional layer that I want to add, because this is where we then just apply the AOP part too. So I don't want to use the naked Twitter API, but really just come up with our own service, which we done. Since that's being called Twitter API, let's just use a service that we call Twitter, and that's a service. And what we want to do is, quickly to check that, what we want to do is fetch a user. So it can be user by username and should return a user. And that's from the Twitter API. Let's check. Should be this one. And what it's doing is return, and that of course needs the private val API, Twitter API injected that we just configured. So it should be API users find by username, and we pass in the username. Then we execute the request and return the data, which consists of the user. So in a real application, we would of course take care of exception handling and whatnot and retries, and we can do this later. But for now, it's really just propagating the call. So we want to look up a user by the username, and we just invoke the API. And this is the call that we will take care of when it comes to rate limits. So let's see if that actually works. We can go to the tests and just have a quick test. Okay, so we just auto wire Twitter, our service. So it's Twitter, yeah, it's just Twitter. And we go back to the test. And what we want to do here is, yeah, let's just do something like Twitter works. That's the test name. So what we want to do is we print line for now. It's going to be Twitter user, and the username is hey Alex Gutja. That should be it. So let's execute the test and see what's happening. So it looks still good at this point. Fingers crossed that it stays good. Yeah. So we can see, this is the actual response from Twitter API. As I said, I'm using a real BIRA token, so this is really live from the Twitter API. You can see it has a lot of data. My ID, my user, the username is here, the real name is here. A few things are probably hidden because I need to request additional scopes, but I'm not going to do this for now because it's still working. So right now, someone who has access to the Twitter service component that we just created could just go off and submit many requests. But as I said, the Twitter API is rate limited, and we're not using the real rate limits because they are really nice actually, because you don't they are not that permissive. But what we're going to do is we just pretend it's much more restricted than what it actually is. So this is where we use Bucket4j. And let me just write it first and then explain what we're going to do. So the idea of Bucket4j is a bucket where you just put in tokens that you can just get out, and they are refilled according to the time constraint that you're adding. So that means you always have to ask for one token from the bucket before you can actually proceed with whatever you want to do. And this works in concurrent scenarios. That's pretty good. And we can do whatever we want if there are not enough tokens in the bucket, right? So for example, throwing an exception. So first of all, how do we build it? There's a builder, and what I want to pretend is that there's a limit, and it looks something like that. So I'm using bandwidth simple. Let me just write it first and then tell you what it does. Duration of minutes, 15. So what I'm saying here is that this bucket has the following constraint. It allows only 3 tokens or requests in that sense per 15 minutes, which is really kind of restricted, right? But we do this to show that it works. But usually what you will find in APIs is also that there are additional limits that are for more frequent requests. So this one is usually the one that's being used for the individual endpoint, and then there's something like a global rate limit, which makes sure that you don't send a gazillion requests in just 2 minutes, something like that, which will bring down the API. So we can just chain these limits. Let's do this here. Bandwidth is also simple. Duration of seconds, 5. So what this now says is this one is still valid. So 3 requests in 50 minutes, but there's an additional constraint which says, but no more than 1 every 5 seconds. So if we send 3 requests in the same second, this is going to be blocked. But if we space them out evenly, or doing it every 10 seconds, every 20 seconds, that's still fine. And then this limit will just hit us at some point. So now let's build the bucket. And what we want to do, I totally made this in the wrong component. Let me just cut this here, because this is of course something that needs to go in our Twitter service. Let's go there. So I'm configuring the bucket in the Twitter service, because what we're going to do is now before we allow a request to path, what we're gonna do is we try to consume. So try consume, and now we can specify the number of tokens that we need to consume, but this is like one request usually just consumes one token in that sense, so that works pretty fine. So we try to consume one of the tokens, and if it works, we just perform the request and return it. And otherwise we would just go with throw a legal state exception, for example. Request is rate limited. Now this would already work, right? So if we now just try to use that, and you shouldn't trust me. Let's run the test here. So I'm now running 3 requests. Now if we go back here, it says only 1 within 5 seconds. So I don't even need 3 because they are just fired like immediately. So if we now run this test, let's see what happens. And we can see it fails, right? So we see the first attempt works. I'm getting back the user that we've seen before, but the second one is rate limited because we already hit the rate limit. We would now have to wait 5 seconds and then it would just work, but it doesn't work right now here. So if we go back to the Twitter service, what now would happen is there's just one function that we're invoking here, but usually Twitter has many more functionalities like accessing other users, accessing timelines, messages, whatnot. So we would now have to replicate this logic, or especially that logic, in every function that we're adding, right? So we would now have to have a new function to access messages, and we would also have to use the same bucket and try consume 1 token in order for the request to proceed. And we now start to duplicating code, which is really annoying. And this is what it's called a cross-cutting concern, because it's cross-cutting across these many functions, and we really want to kind of separate it and only have it in one place. So this is what we're going to do next. We're starting writing our first aspect. So let's do this, and we call that, let's just call it rate limit, and we start here. So I actually don't want to call this rate limit. I get to that in a second. Let's call the actual component rate limiter. And we make sure that this is an aspect. So an aspect is really just the kind of logic that we want to execute and keep it separate, right? And this is what we're doing. We also make it a component so Spring can pick it up. So how does that work right now? So for the aspect, we now have the choice when we want to run it, right? We know that we want to execute a certain function, which is this one. We want to make sure that whenever a certain function is executed, this aspect is applied. And we can do this before the function is executed. We can do it after, or we can do it around. So that means we can manage the execution, and we can do something before it executes and after it returns. And I'll show you what that looks like in a second. Yeah, and the next thing is that we now map the actual aspect to that piece of code that we want to kind of decorate, so to say. So how are we going to do that? We're using an annotation. So let's go back here. And this is why I want to use the name for, not for the actual aspect, but for an annotation. So we're using annotation class rate limit. And this one needs to be, let me just check target. We want to apply that to function. And also let me just write it and then explain what it does. So, and we want to have the retention, which is annotation retention runtime. So these constants look a little bit different from the Java world, but you should still be good because they have pretty same names or pretty similar names. So now we created an annotation, and we want to use that annotation to specify when the rate limiter should be applied. So let's go back to the Twitter service. What we can do now is use the annotation. So this annotation will now be our entry point for the aspect to be executed. And this is very similar to how other aspects are executed in Spring. For example, the add transactional annotation will also just decorate a certain call to a method. And now you will just learn in a second how this works. So let's first copy this over and refactor things a little bit. So we're going back to the aspect, and now we want to encapsulate the whole functionality that we added, the whole rate limiting in that component. So let's just close that. As I said, we now are given the choice when we want to execute our logic, and we're using the around advice. So the advice is really just, should it be run before, after, or around a certain invocation. So what we can do is now write the actual functionality. So it has to follow some conventions. So first of all, we need a way to execute the method that we annotated, right? So let me just see if I can bring this up again. So if we go back to the Twitter service, we need a way of getting a handle to that function so we can execute it from the aspect. And this is what we're doing. Let's go back to the advice. Where is it? Not finding it here. Oh no, it was just called rate limit. So, and there's a way, this is called a join point. So it's called proceeding join point in Spring. So that's a reference to the actual function that we're going to execute. So we could now just return point proceed. And this will invoke the user functionality in the Twitter service. But that would be rather pointless because we haven't applied the rate limit yet. So what we're going to do is, let's also add a logger. Companion private equals logger factory get logger Twitter rate limiter class. So right now let's log in for what are we going to do here? Yeah, checking rate limit. And now we just have the same logic that you've seen before. So now we can just say if bucket try consume 1. And then we're gonna do return point proceed. Otherwise, we just do the same thing, throwing the illegal state exception. And it's a good idea to, let me just write that request has been limited, to just return the exception, because that allows the client, whoever is just invoking the Twitter service, to perform retries and whatnot, because we could also do retries in here, right? But we don't know if the client still wants the request to be executed. So we just try to consume 1 token from the bucket and execute the request. And if that doesn't work, we just throw the exception so clients can figure out, should I resubmit the request or just discard it? So, and now the final piece that's missing is like, how does our rate limiter actually know that it should listen to the specific annotation? And this is what we can do here. We're using the around advice. So this is what it looks like. Annotation rate limit. So this means around the annotation rate limit that we created here, this function is invoked. And now let's go back to the Twitter service and to the Twitter service and just remove the logic there. So we remove the bucket because we no longer need that here. And we can just go back to the initial code that we had here, because now you can see that our Twitter service no longer contains any reference to rate limiting. It has that annotation, and that's fine. It's the same, like as I said, with transactional and a few other annotations. But we're now really just executing the API call and don't care about any rate limits. So let's go back to the test and make sure that this still works. So because if we now execute these 2 requests right away, you can see we get the user, which is also fine. And afterwards we get request has been limited, which means that our rate limiter just kicked in and has limited our request. So that hopefully gives you a nice introduction about how you can use aspect-oriented programming. There's much more to dive deeper into, which we're going to do in a later video. If you have any questions, feel free to drop them in the comments below. Consider subscribing, and I'll see you on the next one.